Hello everyone, welcome to SN and in today's video I'll show you how to build an RAG based PDF chatbot where you can upload any of your PDF and you can ask query from this PDF content. Okay, and we'll be using RAG based embedding technique. So yeah, so first let me show you what we'll be building so that you can have that idea that what we are gonna build today. So this is the application. Wait a minute, let me refresh it. Yeah, so this will be the application where you can paste your Gemini API key, which is absolutely free because we are using Gemini Flash API, which is free up to a certain limit. Then enter. Here you can put any of your PDF. I'll be putting this research paper PDF and then I'll be submit and progress. Now here I'll simply ask what is steganography. What is steganography? That's it. And okay, so this is some basic effect that I provided, okay, which is not necessary. And yeah, so what is steganography? Steganography is the art and science of embedding a secret message into a cover medium be transmitted over the internet. The embedding is okay. And now if you want to see that thing, so here is the PDF and you could see that here we have the information of what is what steganography is, all this thing. Okay, so it's working. Yeah, it's working. So yeah, so before we get into the code, and yeah, you can also download the whole conversation from this CSV file. You can see that we have this whole thing. We have the whole answer here. Okay, so this is the whole application that we'll be building today. So but before getting to the code, let us understand how that RAG architecture works. Okay, so this is architecture I have drawn for you. So first comes question is what is RAG? So RAG means Retrieval-Augmented Generation, which is a kind of advanced AI technique that makes our any chatbot way smarter than any of those LLMs, because instead of just relying on some pre-trained language model, RAG retrieves relevant information from a knowledge source like PDF, docs, any database like .sql file, any JSON file, whatever you provide. Okay, and this is how AI gives you some better answers without getting hallucinated, because lots of LLMs gets hallucinated by some user prompts. Okay, so this is the what is RAG is, and one of the most important aspect of RAG is vector embeddings, which is like the turning text into numbers. So if we see in that okay, so what is vector embedding? You can kind of see that like when you are providing an PDF to an AI model, the first question comes that how that model would understand, like as per your query, that which part of that PDF is contain your answer, right? And this is where vector embeddings comes actually, because things of embedding as a unique fingerprint of text where similar meanings are placed closer together in a mathematical place, right? So now if you can see the architecture, you could see that here we have provided that, wait a minute, so let me show you. So at the first red dotted box, you could see we are providing our documents here. Okay, in the next dotted box, you could see that we have we take chunks from that PDF, or we have built multiple chunks from the documents. Okay, then each chunk is converted into a vector using an embedding model, and in this case we'll be using Gemini's embedding 001 models for this embedding model transformation. Okay, and after going through this embedding model, it will give us this vector where each chunks converted into multiple vector numbers. Okay, because these similar pieces of text will have those similar vectors. Now okay, now imagine that you have all those vectors number, but you need to store that in a database. Now you cannot use any normal MongoDB or any normal SQL databases. For that you need to use vector database, and we have multiple databases, like we have Supabase, we have ChromaDB, we have Pinecone, we have FAISS. So but in this project we'll be using FAISS, which is an vector database. Okay, now why we need that? Because we need to store and quickly search through these vector embeddings, right? And this is where this FAISS comes out, and this FAISS full meaning is Facebook AI Similarity Search. Okay, and it is a pretty super efficient vector database that allows us to find the most relevant information from thousands of text chunks instantly. Okay, and how this FAISS works in our chatbot, you could see that we store all of our vector embeddings from this second dotted box to this third dotted box. We have stored all of this in this vector DB. So when any user, wait a minute, so when any user here gonna ask a question, we convert it into a vector and we'll send that to his vector DB. Okay, then FAISS quickly finds the most similar text chunk. Okay, then this text chunks gonna provide it to this fourth box, to these chunks. Okay, then these chunks will be provided to this context, this prompt, like to this prompt. Okay, then at the last this will provide it to this LLM. Then LLM will create a proper structured answer for your prompts. Then that will again gonna send back to you. Gonna send back to you for the user. Okay, so this is how it works. I've tried to explain this short so that you can understand like how this whole RAG works. So now get into the code base. Okay, so now I am in my folder, and here I have already created this virtual environment. And to tell you how to do that, wait a minute. Here you could see to create a virtual environment, right? We need to do python -m venv my-env. Okay, and then we need to write this command my-env scripts activate. This is how you can create your own virtual environment in your folder, and then you can activate that. And why we use this thing? Because while you'll be installing lots of packages, you won't really want to install that in your local system again and again. So virtual environment is a best practice for that. Okay, so we have activated our thing, and to install we have this requirement.txt. I'll be giving you this txt file so that you can install all the important packages as per the requirement. And if anything gets tricky and if you can't take anything, take help of internet, it will be helpful. Okay. So after that, our next focus will be to create that app.py. Here we'll be start writing our code. Okay. First we need to import packages. Okay, so what we need to import, so for that first we need to import our Streamlit as ht. Then from py-pdf2 we need to import pdf reader. Okay, then we need pandas as pd. Then for embedding we'll be needing base 64. Alright, now we need import os to tackle those API keys. And now quotes for LangChain. Okay, now what we need here, we need from LangChain dot text dot splitter, we need to import recursive character text splitter, recursive character text splitter from LangChain dot text, it will be underscore splitter. Okay, now then from LangChain underscore Google underscore GenAI, we'll have to import Google generative AI embeddings, and this is how we'll be embed our chunked from those PDFs. Okay, all right, now LangChain from LangChain community dot vector stores, will import FAISS, then last one it be from LangChain Google GenAI, we need to import the chat Google generative AI for the flash model. Okay, then from LangChain chains dot questions answering, we need to import load question answer chain, and from LangChain dot prompts, we need to import prompt template. Okay, so this is all the packages we need to install. Now for the last one, for date time, this will be to download our CSV, we need to provide the date and time. So import date time. All right, now our first function we need to create for to get text chunks from PDF. Okay, so we'll be creating one function def, let's say get text get PDF text. Okay, here we'll be providing this PDF documentation, then text, I'll be taking one empty string, then for PDF in PDF docs, PDF reader PDF reader PDF. Okay, for page in PDF reader dot pages, I'll be incrementing this, so text page dot extract text function. Okay, then finally simply I'll return text. Okay, all right. Now our second function would be to get, it's for the text. Okay, now this one is for chunks from text. Now for this I'll be creating one function, which is get, sorry, get text chunks. Here I'll be providing my text and the model name. Okay, now if model name Google AI, then what I'll do, text splitter. Here I'll be using this recursive character text splitter function, and I'll simply provide some parameters that what should be my chunk size. Let's say I'll be taking 1000. Then what would be my chunk overlapping number? So I'll be taking 1000 as well in here. Okay, now I've done that. If this, then chunks should be text splitter, split the text. I'll be providing my text over here, and I'll be simply returning my chunks. Okay, all right, so I've got my chunks now I need to store this chunks after embedding to an vector store. So storing, okay, so chunks and vector store. Okay, now for that I'll create this function. Let's say let's say def get vector store. Okay, here I'll be providing my text chunk, model name, and the API key, which as of now I'll be taking it none. Okay, so I have provided text chunks, model name, and API key. Now if model name is Google AI, in embeddings I'll be using my Google generative AI embeddings, and here I need to provide the embedding model's name. And for generative AI, for Gemini generative AI, we need to use embedding 001. This is the model name for the embedding for Gemini. Okay, for the free one. Now Google API key is the API key that will be provided by the user, right? So my embedding is done now. Now I need to store that in my vector store. So vector store FAISS from texts. This function, I'll provide this function my text chunk. I'll provide the embedding, embedding, then vector store dot, I'll save it to local directory as FAISS index. Okay, so I'll be having a new folder in this directory where I'll be having some of those stored files. Okay, so then I'll simply return vector store. Okay, it's done. Okay, now our fourth function would be to create a conversational chain with using LangChain. So create a using LangChain. All right, let's do that. Right, again, if model name Google AI. Acha, wait a minute, I need to create the function, right? So def, let's say get conversational chain. Okay, here I need to provide my model name, which should be Google AI. Then for the vector store, I'll be giving it none, and for API key for the starting, I'll be giving it none. Initialization would be with none. Okay, then simply start, right? So if model name is Google AI, then I need one prompt template, and I'll be taking it as an empty string. Then here I need to give a prompt, okay, to understand my LLM that what they need to do. So wait a minute, so I have a prompt ready, so I'll be writing that prompt. So answer the question as detailed as possible from the provided context. Make sure to provide all the details with proper structure. If the answer is not in the provided context, just say answer is not available. Okay, available in the context. Don't provide the wrong answer. Okay, so this is how you have to say, this is how you have to train your model, that this is how that model should behave. Okay, now context, then there would be my question. This is how that prompt would work. Question. All right, and then you need to provide the answer. Okay, so the prompt is done. Now my LLM knows how it should behave. Now let us take it into the model. So model chat Google generative AI. Here I need to mention the which model we are using. So we'll be using Gemini 1.5, and be careful with the naming, because if the naming is wrong, then you might get some error at the runtime. Okay, temperature I'll be taking less, so I'll be taking it at 0.3. Then Google API key would be the API key provided by the user. Okay, if you provide any wrong API, it won't work. So that's that simple. So now for the prompt, I'll be using my prompt template here. In template, I'll provide my prompt template that I have written right now, just now. So prompt template, and in input variables, I need to provide this context. And this question. Okay. Alright, now to create the chain, I'll be using load QA chain, and I'll simply pass the model. I'll pass the chain type as a parameter, and which would be in this case stuff. And then for the prompt, I'll be simply passing my prompt like this one. Okay, so prompt and prompt, then simply I'll be returning my chain. All right, another function done. Now I need to create a function so that I can take the user input. So take user input. Okay, all right, let me create another one. Here I'll be creating def user input. I'll be providing user question, model name, simply API key, and my PDF docs, and conversation history. Okay, so now if API key is none or PDF docs is none, I need to provide an warning. So for the warning part, I'll be giving it, please upload any PDF and provide API key. Okay, then I'll simply return. Okay, now I first need what? I first need to chunk the text. So text chunks. Here I need to call that function of get text chunk. Here I'll be calling my function to get text from the PDF. So get PDF text. Here I'll provide my PDF docs and my model name. All right, now vector store. I'll be using this function vector store, pass my text chunk, pass the model name, pass the API key. Simple. Now user question output. Here I need to create an empty string. Now for response output, here I also need one empty string. Okay, now if model name is Google AI. Then what I would want here, understand properly here, first I'll be embeddings, Google generative AI embedding, because I need to embed the user prompt as well, na? So I'm using this for that. So Google embeddings, here I need to provide them my FAISS index so that it can search across my FAISS database, like my vector database. Index, comma, embeddings, allow dangerous deserialization, and I need to make it true. Okay, now a new DB I need to create, FAISS dot load local sorry, I think I've done some mistake over here. In this Google generative AI embedding, I need to provide this embedding part, this embedding model. So I want to provide the embedding model with the API key. Now here I'll be providing my FAISS index in this new vector database. Okay, with embeddings, and allow danger deserialization would be true. Okay, now my new DB is done. Now for the docs, new DB dot similarity search, user question, right? So as per the user question, I'll be run one similarity search across my FAISS database. Okay, in our next step we'll be applying the chain. So the chain, we have this get conversational chain function. Here I'll be providing the name of the model Google AI with vector store. This vector store is this new DB. Then API key is my API key. Okay, now I need to take the response. So I'll be getting the response from the chain. So from chain, one double bracket, input documents would be the docs, and question, my question would be user question that user will be giving me. Okay, now I need to return only my outputs, and I need to make it true because I need only the outputs, right? Not anything else, any metadata, any timing, nothing else. I need only the output. So I've got my response. Now for user question output, I need to take user question, then response output, I need response output text. Okay, now for the PDF names, pdf dot name for pdf in pdf docs if pdf docs else 0. Okay, we'll be taking this pdf names to get that vector stored name. Now to build that conversational history, conversation history, we need to append our user question output and our response output, and you also need to provide the model name, and for the date time you need to provide dot that current date, right? And where we need to stringify the time, so instead of time here I need to simply provide the format of the whole, how I want to show the timing in that CSV file that will be downloaded. So the format would be like this: year, then month, then I have my days, hour, I have minutes, I have second. Okay, and now simply I'll use this join function with the pdf name. All right. Okay, so now I need to create the whole chat design right now. Okay, so for that I'll be using ht.markdown, all this thing, and I have already have that with me, so I'll be using that one. So okay, so I'll be using this. As you can see, we have implemented this markdown, and it only with this indentation, so I need to slip it like here. Okay, so ft markdown, then the whole styling of the whole chat interface. Okay, now after that I need to write some more. So if the length of the conversation history is 1, then conversation history with this empty string. Okay, elif length of conversation history, let's say if it is greater than 1, then last item conversation history would be -1. Okay, then conversation history dot remove last item. Okay, now I'll be running one for loop for question, answer, model name, timestamp, PDF name in reversed, also in the conversational history. I need another markdown for the whole chat design. Okay, now I need to make sure about the conversational session of the whole PDF conversation, right? So if len ht dot session state dot conversation history will be greater than 0, then in df we'll be using this pd dot data frame, where I'll be using this okay. Now I need to write the code to make it available to download those CSV file. Okay, and I'll be wasting time on that, so I'll be just pasting the rest of the code over here. You could see we have if len of ht.session date conversation history is greater than 0, mean if there is at least one conversation history, then and only you will be able to download the conversation history. And for that we'll be creating one pandas data frame of question, answer, model, timestamp and PDF name. In CSV file will be df.toCSV, and we'll be using our B64 to encode the whole message. And here you can easily to download the conversation, click the download button on the left side. Okay, that's it. And here is that ht.snow for this little animation function. That's it. Okay, now we have done our user input code. Now we need to write the main code, like the main function, like from where our the main entry point for the function, right? So main entry point function. Yeah, here you could see that we have the dev main function, where in this first set page configuration we have chat with multiple PDF. This is the header file, header file. And if conversation history not in the session state, then you have our conversation history as 0. Okay, and these are my LinkedIn link, my Kaggle link, my GitHub link, simple as that. And this is the sidebar markdown link of Kaggle, LinkedIn and GitHub. And this is the model name for the radio. This is the API key would be initialized as none. Then if the model name is Google AI, you'll have to enter your Google API key. And if you don't have API key, you can have that from this particular link. Okay, if you don't have an API key, there will be a warning that please enter your Google API key to proceed. Then after that you will be having, like, if you have one API key, if you press enter, then and only you will get to see this code. Okay, you're having a menu, you will having this one reset button, one run button, and here you can easily upload your PDF questions. Okay, so this is to clear conversation history, clear user question input, and this is to reset your Google API key, reset your PDF documents. And else, if you don't have that, if clear button, if user question in session state, this previous query will also be declared. Okay, so these are when you already have the conversation, then and only this block of code will run. Okay, now here how you can upload your PDF doc, ht.file uploader. You can upload your PDF file in here, and there will be a user question where you can ask a question from the PDF file. You'll be giving your answer, and then this user input function will be done with this passing arguments of user question, model name, API key, PDF docs, know that Streamlit, all this kind of thing, and this is the entry point of your whole code. Okay. Streamlit run app.py, and yes, so here we have our application, and now I'll show you how to get any like a Gemini API key, right? So click in this link, you'll be navigate to this page, and click in here, explore models in Google AI Studio. Click in here, you will land in here, get this get API key, come down, and you have this create API key. Okay, now write this as Gemini API, create API, and you need to create some new project for that purpose. Okay, we'll copy this and we'll push it over here, then we'll browse, we'll put this submit and process. Here we'll write what is steganography, right? Now here you will find your answer. Okay, and to download this whole conversation, you have this CSV file, you can easily open it over here. That's it. Okay, so this was our project, and yeah, thanks for watching.